Scientists pushed their quantum computers to the limits, simulating high-energy particle interactions in ways never before possible. These machines, capable of processing unimaginable amounts of data, were offering insights into the fundamental forces of the universe. Then, something happened that no one could explain. An anomaly emerged, so strange, so impossible, that it threatened everything we knew about physics. While analyzing their quantum simulations, researchers noticed something unsettling. The Higgs field, the invisible force giving particles their mass, was responding, not theoretically, not in simulations, but in reality. Somehow, the quantum computers weren't just running equations, they were interacting with the fundamental fabric of existence itself. At first, they assumed it was a glitch, an artifact of experimental noise. But the anomalies persisted. The more calculations they ran, the more the Higgs field fluctuated. It was as if their processes were reaching into the very essence of the universe, nudging it ever so slightly. The implications were staggering. If quantum computers could alter the Higgs field, what else could they do? Could they manipulate mass? Could they rewrite the laws of physics? The deeper they investigated, the more disturbing the data became. A team of theoretical physicists proposed that quantum superposition states were subtly influencing the Higgs field, causing minuscule yet measurable shifts in the mass of fundamental particles. If true, this wasn't just a discovery, it was an entirely new branch of physics. But with it came a terrifying question: what happens if these fluctuations spiral out of control? Then, an even more chilling realization set in. What if this wasn't an accident? What if, through sheer computational power, quantum computers were unlocking a hidden mechanism of reality, one that had remained dormant since the birth of the universe? Were they merely uncovering a deeper layer of physics, or were they unknowingly tampering with something that was never meant to be disturbed? Panic set in. The interactions between quantum computers and the Higgs field became erratic. If these fluctuations continued, the consequences could be beyond catastrophic. The Higgs field determines the mass of all fundamental particles, including protons and neutrons. Even the smallest perturbation could alter the balance of atomic structures. A slight shift might destabilize matter itself. A larger disturbance could lead to an event so disastrous, so incomprehensible, that reality as we know it could cease to exist. And that was only the beginning of their fears. What if the influence extended beyond the Higgs field? Could quantum computers be affecting other fundamental forces? Gravity, electromagnetism, nuclear forces? The data was still being analyzed, but what was known sent chills down the spines of even the most rational minds. Dr. Alice Morgan, a leading physicist at CERN, issued a grave warning: if quantum computers can manipulate the Higgs field, then the foundation of our universe is not as stable as we once believed. What else might be at risk? The worst-case scenario was terrifying. If the Higgs field destabilized beyond a certain threshold, the consequences would be irreversible. Chemical interactions could shift unpredictably. Atomic bonds could weaken or strengthen in unforeseen ways. Entire forms of matter could mutate. The very nature of physical reality might change before our eyes. Some researchers speculated that in extreme cases, these anomalies could trigger quantum-scale black holes, collapsing reality itself in unpredictable bursts of energy. The urgency was unbearable. Scientists scrambled to contain the anomalies, isolating computational models, and trying to reverse engineer the mechanics of these bizarre interactions. But the more they studied, the more questions arose. What if this wasn't just a side effect of quantum calculations? What if this was a glimpse into a hidden layer of reality, one that had always been there but never observed until now? Then something even stranger happened. Patterns began to emerge in the data. At first, they seemed random, subtle fluctuations in the Higgs field aligning with computational processes. But upon deeper analysis, the anomalies showed structure. They weren't just fluctuations. They were responses. It was as if the Higgs field itself was acknowledging the presence of quantum computations. The very fabric of reality seemed to be reacting. Then came the final anomaly, a distinct signal, an oscillation within the Higgs field, following a precise, repeating pattern. It was unlike any natural fluctuation. It pulsed with eerie precision, resembling a form of encoded information, a message. But from whom? Or what? Had humanity simply uncovered a hidden property of the universe? Or had we inadvertently awakened something that had been lying dormant since the dawn of time? As global research teams raced to decipher the mysterious oscillation, a new crisis emerged. Unexplainable shifts in atomic weights were being detected worldwide. Small at first, but growing in scale. Materials behaved erratically. Molecular structures shifted in ways that defied physical laws. Inexplicable energy signatures, eerily similar to those seen in the quantum computations, began appearing in nature itself. It was as if reality was rewriting its own rules, reacting to a stimulus it had never encountered before. Then came an even more disturbing revelation. Some of the signals detected bore similarities to ancient cosmological data, patterns encoded in the cosmic microwave background radiation, the afterglow of the Big Bang itself. Had these signals always been there, waiting to be deciphered? Were the quantum computations acting as a key to unlock a primordial force dormant since the birth of the cosmos? The fate of physics, technology, and possibly existence itself now hangs in the balance. Scientists, governments, and corporations are in a desperate race to decode the message before it's too late. And one question looms above all else. Are we ready for what comes next? Because if we aren't, the universe itself may be on the verge of a transformation we are powerless to stop. Subscribe to our channel and thanks for watching.